All right, this is APAB Calculus, and we are doing the midterm review packet. This is free response 21A, which is one of the non-calculator free response questions. All right, so we have a piecewise function defined by two polynomials, but it's worth noting that there are two constants that we don't know. There's a k right here, right, and there's a p right here that we don't know those constants, so that's going to be relevant at some point. For what values of k and p will f be continuous and differentiable? So here's the deal. Continuous, right, will mean that the limit when I approach from the left side of 1 is equal to the limit when I approach from the right side. So let's start with what f is continuous is going to look like. If this is a free response, which it is, I need to make sure that I show proper notation. So I need to write the left-sided limit equals the right-sided limit. I need to write it as limit notation. If you don't write it as limit notation, you're going to lose a point. I'm just warning you now, on free response, the AP is going to want to see the actual limit notation. Okay, so for f to be continuous, this is what I'm looking for. So on the left-hand side, that's going to mean that I plug in a 1 and get 2 minus 1. On the right-hand side, I'm going to get 1 plus k plus p. So I end up with an equation that is 1 equals 1 plus k plus p. So essentially, I can clean it up a little and get just that 0 is k plus p, and then we'll go from there in a sec. So I'm going to need this equation. The second equation I'm going to need is about f prime. So differentiable is the same set of rules, but for the derivative. So if f of x is this piecewise function, the derivative is just what happens if I differentiate each of the pieces and keep the function rules the same, but without the equal to. So the derivative of 2x minus x squared is a 2 minus 2x, and that'll be for x values less than 1. The derivative of this is going to be a 2x plus k, no more p, and that'll be for x values greater than 1. So when I follow the same set of rules, right, I'm going to use the left and right limits, but this time with f prime, the limit as x approaches 1 from the left of f prime of x has to equal the limit as x approaches 1 from the right of f prime of x. And again, absolutely need this limit notation if you want full credit on a free response. So now, when I plug in 1 from the left, I get 2 minus 2. When I plug in 1 from the right, I get 2 plus k. Well, it seems to me that that says 0 equals 2 plus k, so I now know that k is negative 2. Well, now that I know k is negative 2, it's a lot easier to find p, right? Because once k is negative 2, 0 equals negative 2 plus p, 2 is p. So this is a pretty common question where they give you a's or b's or k's or p's, where you have to find the value of them when a piecewise function is continuous and differentiable, and it pretty much always boils down to this left limit equals right limit, and you have to do the skill twice, once with the original function and once with the derivative. Sometimes it's multiple choice, and then you can skimp on the limit notation a little bit, but if it's free response, the limit notation is incredibly important to get you full credit. Don't sacrifice easy AP points because you don't like limit notation. Please make sure you use it if you're asked this question. So that's my answer.